I am going to share my screen, and I'm first going to just say that if anybody wants my slides, they're in the category for the Data Modeling Day 2023, and Lydia's going to help me get them on the show
Yes.
page.
Yeah.
And so if anybody wants them, you can go download them. Um, as Lydia said, and I bounced these slides off of her, so she's a co-author here, and will help me with the really hard questions. I'm pretty sure. And what I want to talk about is the difference in using Wikidata in the semantic web space and in the application space, at least from the kinds of applications I have seen and created. So a lot of this is personal experience, and I wanted to cover a bunch of different things, and so there may be areas where people want to ask a question or stuff, and I'm not watching the chat. So Lydia, if you want to jump in or somebody wants to
Yes.
help me with the chat, we can do that. But I wanted to go through the use cases and some thinking about how to design the actual instances and the data that's in Wikidata, and how some of those design issues then impact the problems that people are seeing. And I've also kind of been thinking about how could this turn into a new top level conceptual model that would make it easier to like find problems or make it easier for people to do these applications. So that's kind of what I'm going to talk about, which is this broad range of topics, use cases. Um, the thing that's really important to think about is that these kinds of the way I'm thinking about it, these kinds of use cases are not human um, query generated, not looking for very specific information like how many Hannah did this, how many awards did Meryl Streep win? But very kind of broad things that are going to help extend a business's, somebody's research, their existing data, their existing concepts about data modeling, and extend it using Wikidata at a very broad scale, and doing it programmatically, because human beings don't scale very well at specific queries. So what kinds of things have I specifically used? Looking at the synonyms, i.e. the alternate names that are provided to help with natural language parsing and encoding, looking at the identifiers from other data sets to help with data fusion and the integration of my data, my internal or my incorporated data with the Wikidata information. How to map my relationships or the things I'm interested in. And one of the things I'm really interested in is eventing that's happening in news. So who's the actor in a murder, say, and who's been murdered, and did the murder have a reason or a theme to it? Those kinds of things are these relationships, and how can I pull more information out of Wikidata for this? And in addition, providing historical, cultural context, because that's missing a lot. And sometimes, a user of an application will say, "Oh, I know what this means, but what other things was this entity involved in, or things like that." And you can then pull that information from Wikidata. So that's kind of this whole follow your nose, Tim Berners-Lee use of semantic web, of linked data. I'm interested in this entity, but what else did they do? And can you give me more information about that particular thing they did? Wikidata is amazing for that. Um, the other thing that's often done, and is one of the kind of key features of semantic web, is not only to do the follow your nose, but to do reasoning and inference. And not only textual similarity, but is the meaning of something, semantic similarity, right? So again, that comes to expanding your knowledge, discovering new things, But reasoning and inference can also be used for data validation and this consistency correctness checking. And I have an example of that way at the end, which I hope to get to. So there was this brief mention that Hannah gave too about improving ChatGPT and things. So that was also a key use that I have for Wikidata 2 to validate information returned by an LLM, to reduce hallucinations, to um, I get information back sometimes when I do a query, like the house. If you see the text "the house" with a capital H, and you're in the United States, you're typically thinking about the House of Representatives, and natural language processing will say that's an organization. But if you query, you might get back the Wikidata entry for a house, which is a building, or the Wikipedia entry, and then you can ask actually ask ChatGPT, did this building thing, does that correspond to an organization? Probably not. And so you can use these, use Wikidata both ways to help an LLM, but also the LLM to help make sure you found the right entity. If you're just kind of querying by words, and you can do training data and other things like that, but there's a lot of very amazing usages just beyond, Wikidata and query for very specific things. Um, so what I want to talk about next are some of the challenges, and I'm not going to go into great detail because this was done in the opening session. This was talked about in some of the other sessions, but um, and I just want to talk about this overlap and ambiguity. So scientist as a profession versus a person. It's a subclass of a person and an instance of a profession, and a person's not a subclass of a human. That I find a little confusing, although I understand that this is a person in a role. But then you also have this concept of a role. A role exists. It's a social role. It's a subclass of an identity relative to another. Um, they're all labeled the same. So if you're doing a search as a researcher who's not aware of some of these challenges, you get this role, which subclasses from that role, which has different semantics actually, and it gets a little confusing. This is back to the semantic similarity. But then if you're thinking about locations, is it a geographic location, a geographic region, a physical location, or a geographical area? Those are all possibilities. So when a researcher comes and is looking, or an application developer comes and says, I need to know about locations, you kind of scratch your head and say, what cue am I actually looking for? But you have the problem too at a property level of, if I am looking for somebody who created some software, is it a developer, a creator, the author? How do you, there are similarities and differences, and there are some things that hopefully could be done to improve this so that you actually can better capture the semantics, or follow a property tree, even like you can a sub property tree, like you can follow a subclassing tree. uh and when I brought these up, I was actually going through those challenges, but also kind of looking very concretely at things that would be commonly queried. Humans have a maximum subclass depth of 9, which is amazing that there are 9 levels of human. And I have a picture of it on the last slide. Geographic location gets recursive at a depth of 16. So if you keep querying down, you go forever because, whoops, I jumped too far. This one is a subclass of this, which points back to that's a subclass of this. And you get circular. Tool gets recursive at a depth of 22. Um, that's a problem if you're querying a subclassing tree. And then you have these problems of A is a subclass of B is a subclass of C, then C comes back in subclasses A. That doesn't make a lot of sense. And like I said, you can use the subproperty of P1647, but when I queried it, only I think now 900 triples actually use it. Um, when I wrote the slide a couple weeks ago, it was 898. And this is the 9-level human, which is a African queen mother, who points to the queen mothers in Africa, who points to queen mothers. You take two different paths here, go directly up to queen consort, or you actually you don't probably need this. You go up to queen consort. You can go over here and go up to here, which is one subclassing path, or you can go straight to queen dowager, go up to woman, a female, human, a human, and then all of these super classes. So that's your 9 levels of human, even though it's also involving the roles the person played and not just human. Okay. And all of the properties for, oh, Lordy, come on. All of the properties for that particular instance are listed right here. Who's their child? What jurisdiction? Where they ruled? What kind of clothes they? I'm going to hide that. Whoops. What kind of clothes they wore? And that was this says the complete list of properties for that person. So in this picture, you can see that you're kind of conflating both roles that the person played and things that happened there with being a human and having children and ancestors and those kinds of things. Number of properties. I know a couple people, Hannah mentioned this too. So I'm kind of building off of some of the things she said, that people have a hard time understanding if you have 11,000 properties, or more than 11,000, how do you find the one that's relevant? Now, 8,300 plus are identifiers, but you can't easily identify them as identifiers without digging closer. So that still leaves about 3,000 properties. And this is just one example. So I'm going back to this concept of locations. Um, I'm interested in locations in a query. And I think I went with P159. And the locations in a query 13 related to geography. I think there's more detail in the next. No, there's not more detail in the next slide. But you have all kinds of a location property. You have a headquarters property. You have a location that's a place of death. A direction, a medical evacuation property, and they're not organized in a hierarchy that says these are all giving you locations as a result. Something is located in or on a physical feature. You kind of have to know that if I want to get all of these locations, I need to start doing all these kinds of queries. If I'm only interested in place of death, hopefully I just do P20, right? But it kind of is very difficult, because if you're looking for maybe something that's been mentioned in the news, and what locations are the most often referenced or something, do you put these all together in a property path? How do you actually use this in a broader context? And then how does a researcher actually know that they found the most relevant or the most important ones, or even all of them? Um, I'm referencing a paper that Lydia actually was a co-author on, Wikidata, the making of, which just came out. And so there are challenges there, that how do you share semantics within it, with other projects, with the world in general? There was a reference to the entity schemas, that they were informal, vague, and ambiguous. And there was a reference in this semantic web keynote that a sufficiently formal, unambiguous, declarative way of sharing intended interpretations is needed. Um, And beyond that, and that's for going external, but beyond that for the editors, how do you keep quality? How do you increase coherence of the data that's actually in Wikidata? Um, I mentioned earlier about increasing knowledge and using this in semantic web applications. And one of the big things is information extraction, creating structured data from text. That's a huge thing. Um, and I've actually pulled information extraction from the Wikipedia discussion. Uh, a- and it's about relating everything that's talked about in the text. So this example was actually in the Wikipedia entry. You have newswire articles on Latin American terrorism. Um, you kind of figure out, you create a template, you figure out what kinds of things I want to look for. Who's the perpetrator? Who's the victim? What kind of weapon did they use? When did it happen? Is there a pattern? Those kinds of things. Which means that you actually have to understand that there are different terrorist groups that take different approaches, that use different weapons, that have different reasons and motivations, et cetera, et cetera. And this can be found in Wikidata, but you have to figure out how to find it. And then once you have it, you can improve your extraction by, again, getting alternate names, getting synonyms, maybe looking for terms, et cetera, in the text that you're reading that have been highlighted, that have been learned from Wikidata. But what that really, at the end of the day, requires is this very well documented entity hierarchy and a basic set of properties. And I think in the first session there was some discussion about significant. What are the significant classes? What are the significant properties? And can we get those documented, solidified, and clear, and very visible and searchable? Um, Here are some more examples. So I'm looking for fictional characters, right? You can create a very complex hierarchy where everything that can be fictional is a subclass of something that's not fictional. A human and a fictional human, a city and a fictional city. Why not use from the narrative universe or something similar to that, a more general property than that? Or you can then go down this entity subclassing hierarchy, which I looked at. You have this concept of imaginary, you have a concept of a non-existent entity. There are all these different ways to do things, which are, for a human being, you look at it and you go, oh, okay, so this is for, John Smith, he's imaginary. Okay, or John Smith is from the narrative universe. But when you're looking at it from this broad, I'm querying to learn perspective, it's very difficult to track all these variations. And then again, from the first session, I had some of these notes before, but it was interesting because people were talking about this problem with organizations. What is an organization a part of? Where is it located? An organization is not just its location, and a location is not just an organization, but then you have this complex organization tree that goes 50 levels deep with 137,000 plus entries in it. Yeah, editors and users will find this difficult. Or another problem is making discrete subclasses of something, like big city is a subclass of city and it's labeled with a population. But that's more than a certain amount. But what happens if the day after you designate Los Angeles as a big city? Something happens. There's this huge earthquake or something, and Los Angeles now is destroyed, and it doesn't have 100,000 inhabitants anymore. It's got 10,000. It's no longer a big city. Um, you could have things that work like this, but query with a property. Like, I just want to look at population, and I'll decide what's big and what's not big. Don't decide for me, and make me do this P279 star thing all the time because I time out a lot. And Hannah mentioned showed that, but a lot of people have the timeout problems. So Lydia, anything that I should touch on before I move to the next session? I mean,
No,
next.
let's move on because we're already 20 minutes in.
Okay. Um, so what I want to say is, let's think about the overall model. What might make sense to you as a person doing something at a very specific time, think first, is it based on an aspect or a perspective? And I've used this before and everybody relates to it. Think about a candy bar. When sharing with friends, the property you care about is, can I split it up evenly? You know, is it a night? Does it, the candy bar have slots in it that I can make to make sure that everybody gets a piece? Or what sizes does the candy bar come in? Because then I'll know how many people I can share with. But if you have friends or children or know somebody with an allergy, you really don't care about what the size is anymore. You care about, does it have peanuts in it? Does it have dairy in it? Things like that. And so when you think about, I want to get a candy bar and then I want to go query these different aspects of it, those are its properties. Or thinking about time, a lot of people go down this path of something that endures forever or something that changes frequently, but it's really a concept of time. So if you think about geologic time, you don't care about a minute. If you think of, and maybe you care about billions of years only, but if you think about computer time, a minute's an eternity. And I said, and your Blaze graph query times out too. Beyond that, so kind of think about aspect and perspective when creating modeling. Does another domain do it? I love the entity schemas design, approaches, but I also thought that there are some things that could be added to the entity schema. And I think I brought this up in the entity schema discussion. Um, in the second or third session on the first day, uh, a short description of it, what you use it for and what you don't use it for. Somebody is in a role, you don't use it to describe a human, you use it to describe the relationship of the human to that particular occupation or a social role that they play, whatever. It would be wonderful if there was a way to create at least a table that showed the main concepts. But a diagram is even better. It helps people like focus in on these things. And then when you come down to this, what's mandatory, what's optional, what's single valued, multi-valued, this shucks definition is totally great. But if you had examples of at least two, and sample queries that use them, that would really help people think about, the environment and what they're doing. And then instructions on extending. Please do not ever make a subclass of this, or please do not ever make an instance of it, those kinds of things. Or always make a subclass of this. This entity should never be instantiated, right? Um, then thinking about the overall model, do you want to create a subclass right now? Of the 2.7, these statistics came out of this paper, Integrating Wikidata into Yago, a very good paper. Everything in my presentation is linked. Out of the 2.7 million classes that are defined, only 3% are instantiated. So how do you actually know that this is right? That's a problem, and that's a problem that ontologists and people who create models have all the time. They think they know, but without actually having real instances of things, they create a really deep hierarchy that's not necessary. Um, should a new subclass be added, or can we use a property? And this is another example, reusing part of relationship versus P131, which is an administrative territorial entity. You have all of these other kinds of part of um, that are described. And so when I look at, um, and again, I want to talk about, subproperty of, but I'm not going to highlight that. I wanted to select where something is a part of a whole, and the whole is a kind of 56061, which is an administrative territorial entity. So what is a part of an administrative entity? What's located in an administrative territorial entity. So I use these two parts of and located in. Um, P131 located in administrative territorial entity. Um, and the part of a whole returned 1,790 results. The located in returned 37,600 results. Clearly, this is the winner. But if you really wanted all the answers, you really need to query both of those things and maybe some of those other um, P properties that were shown on the previous slide. There were only of those two when I asked for ones that overlapped. Only 138 results overlapped, where somebody declared both part of and located in. And so here's the example of the P361, which is part of, and you have things like, this house is located in this administrative region, this tomb is in this administrative region. It's true, these are all administrative regions. And here you have the ones for part of. No, for local. Well, here we go. That one was, yeah, this one's 361 is part of, and 131 is located in administrative region. The Buenos Aires Lawn Tennis Club is located in Buenos Aires, or this embassy is located in Buenos Aires. It's similar. It's semantically similar, but the properties are different. So if you go through this, and I want to make sure I don't go over time. Um, what I've always used as an approach to modeling is something called systems thinking, and this is a link to the Wikipedia article on systems thinking. Um, but you want to think about the big picture first and then your specifics, because if you go from the ground, from the most specific up, you sometimes run into problems related to, do I really need this? And when I'm looking at one thing, it makes total sense. But if I'm looking at a bigger picture or commonality, it doesn't always make sense. What are the entities? What are their relationship? What forms and functions do they take? What boundaries exist? And wholes versus parts is very, very significant. The whole is always more than its parts. It serves a bigger function. It takes different forms, etc. But the parts are always more than just a piece of the whole. And you can even see part of, the temple that's in, in this administrative region is different than the administrative region, but it is a part of it. So you can just see that very clearly. Um, Worry about what's in and what's external to a system. What's the hierarchy? Does a system have component systems? So this is a part of that, is a part of that, as opposed to, they're not subclasses. They're distinct entities. And then how are they similar or different? How do they relate? But a key kind of thing to think about is what's constant, what's invariant and stable about a system. And a system could be a person too. It could be a body. It could be, a biological process. It when you say systems thinking, it's not just a, big system like a car or a road system or things like that. What changes? How do you track the changes? How do you identify the thing? What's typical? What's exceptional? And when you're doing exceptional, it should be important, not something minor. You want to focus on what's really important, and then what properties define the system, and can you look at the system or the problem that you're trying to solve differently? So that's kind of some modeling thoughts. I could talk quite a bit longer about that, but I'm going to make sure that I get through all of this. Top level concepts. The current Wikidata top level, the key for me, I think, is building on what exists today. I have no desire or no interest or um, I don't want to recreate a wheel. Build on concepts that are already used for instances. There is no way I want to incorporate philosophy-based ontologies and have any deep philosophical discussions about what is knowledge, what's an endurance, what's, I don't want to have any of those discussions. There is actually a Wikidata ontology hierarchy that's on this top level ontology page list. Um, there's 1,099 items in its subclass from this concept of entity, but it gets very strange because it goes it's a bot that does it, and the hierarchy is created, and you start with entity at the top, but then you go all the way down to a hammock hook and a block of postage stamps is a subclass of entity. Now, I agree, but that's not a good top level hierarchy. So it's really important. Um, that has to be refined down. And the classes in this hierarchy are mostly unused for instances. I think when I queried for an instance of anything in the whole hierarchy, I got 14 instances. So clearly that's not being used. And you do get some strange overlapping, incompletely defined things like something is a subclass of entity, being is a subclass, copy, part. These are all subclasses of entity. They're not subclasses. This is a relationship. This is a relationship. I don't know what something is versus being, that's kind of a problem. And then, like I said, you have things like hammock hook, subclasses object, and it's only two links away. So entity goes to object goes to hammock hook. That's a little strange. And you need a property hierarchy too. I strongly feel that way. What that would achieve, it would really give a hierarchy to guide and define these new classes, to make these design patterns, to make these entity schemas, um, clarify these definitions, couple it with structural and semantic similarity so that you can actually better declare inconsistencies, invalid issues, and broadly query then across concepts. It can totally, in my thinking, exist alongside the current declaration. So you don't break anything, you add to it. And then you can apply reasoning to it. And I have an example of that. So I was kind of thinking about what would be a good top level source. Certainly the Wikipedia subject list, which is right there, culture, geography, health, history, people. That's a good list of concepts. The Wikidata subgraph hierarchy. Let me go there. And here's all the links to that. Scholarly articles, astronomical objects, humans. Now, this was done a couple years ago, so these numbers will not be current, but they designations are right. This is a very reasonable way to think about top level. But there's other things too. There was work that was discontinued in 2017 that mapped to schema.org. Now, if you're familiar with schema.org, a lot of people use, developers use schema.org to provide semantic context to their web pages and things like that. That's why it was created. So it is not appropriate for everything, but it is understood. And there was work on this, which maybe should be started up again. Yago, which I had mentioned before, and the paper that was written also maps to schema.org, and describes some of the ways that they have used schema.org to supplement migrating Wikidata into Yago. Another ontology, an ontology which is widely used, at least in with the researchers that I've done work with, is the DBpedia ontology. So that's another possible source. And oh, I don't have a list of the DBpedia, but here I have a list of schema.org. So just take a look at, take a look at this creative work, book, movie, music recording, audio objects, events, health. You see a lot of similarity here in schema.org with the data that's actually in Wikidata. Um, so here's just my thoughts. I'm saying this is thoughts. This is not fully fleshed out yet. Mappings can exist alongside the current definitions. This concept of entity is like a thing, is like an owl thing. Go down this kind of thinking about what would be the next level down. It wouldn't be something or copy, but it would be physical or legal agents. This is like combining human and legal persons. So um, we're not trying to conflate I have an agent that did something in an event, and it could be the president of a company acting for the organization, or it could be the human. I don't care, but the event is really the agent is really the organization, even if though a human does everything for it. Physical resources like food and tools and machines and all of these things. Biochem is very important, and a lot of work's gone into that. The genes, the proteins, the taxon. Intangible is something that comes out of schema.org. And that's for all these things that kind of don't fit anywhere. An occupation is really not something tangible. It's not the person, it's not a resource. A language, English, French, a structured value, these science, these are what schema.org calls intangibles. Creative work, locations, and again, astronomical entity then would fall under location. Um, Times, events, and occurrences, which gives you a lot about history. And then I kind of said this works better as multiple inheritance, that you have a fictional entity. It can be anything. So if you say human and fictional entity, multiple inheritance, it's a fictional entity. So, you make a movie about Brad Pitt, or somebody just did Harrison Ford. I think it was on Disney Plus. You have Harrison Ford, the real person, and Harrison Ford, the fictional, some kind of entity that's fictionalized, that's based on his life, but it's not him. Those are two different entities. One's human, and one's human plus fictional entity. What are the significant top level entities? So map those first. Clearly, what's the most important, and then also map significant properties. And this list of properties was actually brought up in one of the sessions on the first day. Include properties to clarify participant in an event, P710, versus having to use a qualifier and an object has role. If you make a subproperty, use P1647 subproperty, you can clarify the role that somebody plays. And then create entity schemas for those high level entities. So it's not an entity schema for dogs who have won some kind of award or something like that. It's not that low level one. It's here's how you approach modeling a human or an organization. Think about these very significant top level entities. If you want to think about moving to RDF and OWL, which is one of the things I'm really interested in, RDF and OWL distinguishes data properties and object properties, but this is already captured. If I do a special entity data and say I want like Douglas Adams TTL turtle information, you'll get things like the date of birth property. You'll have Douglas Adams date of birth, but then you can also look up WDP 569 and know that it's date of birth, and you can get all this detail out of it, and what's an object property that versus what's a data type property. That all just comes out. So I'm not worrying about doing that. That's already there. But you can also then go down a path of more formal semantics. Instead of saying this property should always be single valued, you declare it as an OWL functional property. If you're saying A and B are inverse properties, you can, or inverse class, inverse properties, you can say inverse of. Properties that are applied from both directions are symmetric properties. That detail is in constraints and in documentation, but it's not formal. Formal meaning of officially defined. And very powerful is this concept of disjointness of concepts. For example, a physical or legal agent is not an intangible, is not a creative work. So if you get these weird setups, like a meat scientist, which I have an example of, it'll say it's disjoint. And in addition, you can use restrictions. There's all kinds of restrictions, like object properties. I can only relate one thing, or I can relate only three things using this. It's some kind of triad. I can do a regex. This is literal value. I can, do other things like that, or property cardinalities. Those are all there, but you can define what's disjoint, what's equivalent, saying that a teenager is an individual whose age is between 13 inclusive and 19 inclusive, and that's all it is. And you can define that using these kind of equivalent object property or data property definitions. They're all specified in OWL. So what I did was I took meat scientist, which this is its number, and it happens to be an instance of meat and an instance of scientist, which is an error clearly because somebody took field of occupation meat science and made a meat scientist. I mean, a human is kind of meat, I guess, but that's kind of wrong. If you're going to do it, map it to the new top level concepts. Meat's a subclass of a physical resource. Scientist is a subclass of intangible because it's an occupation. I output all the triples from Sparkle for meat scientist, meat and scientist. So I just output all those triples. I took it as a tab separated verbose, converted it via Python to RDF. And if you want to see the Python, it's in my backup code. That's there. Um, and and then define that it was distinct. And I should have defined it at an intangible and physical resource level, but I was doing this quickly. So I just said, hey, this is disjoint. A scientist is not a kind of meat. Just for this example, in the conversion, if you look at the code, each superclass is an OWL class. And I took P79 and redefined it as RDFS subclass of. It's just a simple substitution in the code, easy to do. I loaded it into RDF on a free cloud, and I ran a consistency check and asked it to explain it. And it said, hey, this particular instance violated that 901 is disjoint with scientist, is disjoint with meat. So you asserted that, and then you asserted that the meat scientist is a kind of scientist and it's a kind of meat, or a scientist in a meat. So it says, hey, this is a violation. You can't do that. It doesn't make sense. So you can start to do those kinds of things very easily. And Lydia brought this up for me. I'm going to be right on time. What about instances like 143, 842? And I said, I would think that was something called a contextual entity. So it defines that a specific entity type, in this case, the example we used was Uganda at the 1968 Summer Olympics. This is defined as an instance of an Olympic delegation, which totally makes sense. But the whole thing is not just an Olympic delegation. It's an Olympic delegation in a specific context. And that context is the 1968 Summer Olympics. That exists. It's 8429. It's modeled as an event. And you do have a relationship between the delegation and being a participant in this event. And so this is the information that's available for Uganda at the 1968 Summer Olympics. You can get this information, but what I'm saying is that when somebody looks at this, they are not just getting an Olympic delegation, which as a concept all alone doesn't make sense, but they're getting it in a specific contextual entity, in a specific context. And if you have a context property, you can easily find that. And so that is the entire presentation.
Thank you so much, Andrea. There, people are already starting to fix stuff which is great. And there's some agreements, some disagreements with what you were talking about, as I'm sure you also expected. Um,
I totally did, and I have these comments like, what else could be problematic, and it's just some thoughts, and that's one of the reasons I wanted to give this talk is for people to disagree because this is just my view and my perspective. That doesn't make it right.
right. But super useful to get this discussion going. There's a question. Is there any good tool to draw and discover subclassing loops?
Um, no, what I did to make this drawing appear, um, I actually probably could come up with a good Sparkle query that does this. We could probably most of these kinds of errors I could probably find with with um, with a query. I just have to think about how to write it. So if we put that in the Etherpad, I will make sure to add that and then add it onto the helpful queries page, right?
Cool. Um, then Jan was rooting for the Wikidata usage instruction property that should be used more. James was talking about how, for example, uh, chemical entity modeling was a deliberate choice to model that as a molecular species, such as methane, as a class of molecules rather than an instance. Of course, we don't want to instantiate a particular methane molecule. So 1 million chemical species without an instance is not a bug, it was a modeling choice in that particular case.
Yeah, and I have to say, just this came out of people trying to use Wikidata. That doesn't mean it's wrong. I was more because I did not want to query every time I tried to do some complex queries, I timed out on WDQS. It was more this point about 2.7 million classes defined, but only 3% are instantiated. That was the real point. I wasn't trying to pick on this. I just found it in this text and
Mhm.
talked about it. There are good reasons, and actually that would be great, like to have something about chemical entity, which is high in the hierarchy. Um, and talk about this is a modeling choice. You would not clearly instantiate every methane molecule that exists in the world.
Mhm.
Um, but how do you link it? How do you use it? That's where those entity schemas would come in so be so important.
Yeah. And then there was a discussion now around people being afraid to change something because they're not really sure how much some weird modeling choice is actually used, and uh, asking about how to measure the usefulness of an item apart from having backlinks to think about this choice. Do you have any thoughts on that?
Um, I think again, it's something we should think about in terms of Sparkle queries or some ways to actually um, figure out usage. And I don't have any immediate answers, but that's a really valuable question because I know that some of these modeling problems exist because Wikipedia doesn't use Sparkle queries. I wish they did. Um, and some of them exist because, as was discussed, you don't know in when you're doing the modeling. I was listening to the modeling clinics. You don't know what problems a change might create, and it's because everything is so intertwined. So again, that's another thing I would love to think more about and maybe put some thoughts into Sparkle queries or some discussion pages.
Mhm. We're unfortunately at time. There's one last thing from Peter, who says it would be super useful to have a public clever system that contained Wikidata, just so that these queries are currently time out in WDS can be run. And there actually is one, and Tuka already sent a link. Thank you, Tuka. Um, I'm
Yeah,
sure
I
that
tried I tried some of the things in Clever, but some of my queries got more complex, and
hmm,
then I got, like, the errors that I would have to play with Clever some more, and that is a to do on my part,
mhm,
um, to see if I can, get that to work because I was playing with Clever. I was actually, just if I don't think it's up here anymore. I was playing with Clever. I was playing with Yago. I They all have public endpoints, and that would definitely help.
mhm. Cool. Thank you so much, everyone. I know there are a few more questions and thoughts in the chat, but unfortunately, we are out of time. It would be great if you put them in the Etherpad, and then maybe Andrea can look at the Etherpad
That
and
would
answer there.
that would be wonderful. I would really love it. Criticisms, other thoughts, other things that you have problems with, weird things like this contextual entity, or whether you hate that idea. Um, I would love to hear it because I didn't want to have a blank sheet of paper and say, what should I do? But I also, it was more like a sheet of paper that you throw all the tomatoes at.
Great metaphor. All right. Thank you so much again, Andrea. And we're closing this session now. We'll meet again in a few minutes for the next really tough modeling challenge after we've broken our brain with this one. And we're going to talk about modeling gender.